Today we will look into a real-world optimization that works by leveraging the PHP engine optimizations, and it's on an open source library that you probably use yourself. I talked about this engine optimization before in these two videos when we looked at the hidden speed tricks and empty versus identical operator. This time we have a real-world use case of this optimization where my colleague Tim improved the performance of the paragonie constant time encoding library by 30% by adding just 2 backslashes to the code. Let's dive in. The paragonie constant time encoding library serves a special purpose in security. And what it does is it allows you to encode a string at a constant time. So it's not possible to guess which values have been or which secret values have been encoded to a base 32 string, for example. The time for encoding, decoding various strings is the same. You can find more information about constant time attacks and cache timing attacks in this blog post by Anthony Ferrara. It's all about time, and he does it based on an example for comparing passwords, which PHP internally has the function hash equals for now. And constant time encoding is in the same space, a little bit different. There's a blog post on the Paragonie initiative blog about this library as well, explaining the background and what it's used for and its origins. So where does performance come into play when looking at this? First, this library, constant time encoding, is an abstraction on top of either the Sodium extension that is part of PHP core since version 8.2 or a PHP-based implementation. So if we look at the code, we can see the encode function checks for libsodium or sodium extension and uses a function of sodium to convert a string into a hexadecimal representation. And if it's not available, then it runs this PHP-based implementation of the same conversion. And the PHP-based implementation is obviously much slower than the sodium-based extension. However, that is not the thing that we want to look at. Instead, what we want to look at here is that we see the code is using a backslash string length function to address an opcache optimization where it avoids running the string length function as a sort of PHP function implementation, and it has a native engine level implementation of this function that is much faster. It's done using a backslash to prepare, so the function is imported from a global namespace. And this makes these functions, calling these functions quite fast because it converts it into an opcode and it's not running a function. However, if we look at the case on top here, we see that the extension loaded call is not imported from the global namespace. And that is actually a problem because extension loaded also has a shortcut where you can avoid calling this function and it can directly check for that. And the same is true for the sodium bin to hex. It doesn't have a direct opcode to check, but at least by avoiding the lookup, we can save some time as well. So what is the change that we want to test here? Let's go back to what Tim provided as a change. So what does Tim's performance optimization with regard to importing global symbols do for this library? We look at the files changed. He changed 2 files. We look specifically at the hex PHP because we saw that in Visual Studio Code before. Prefixing extension loaded and sodium bin to hex in 2 different places, and doing the same, also importing constants directly instead of doing the lookup. So avoiding sort of one lookup that is unnecessary here. And we can see for this very simple script here that he has a performance difference between those 2 approaches where the optimized version is running much faster, so 1.76 times faster than the one without this optimization. Let's look at the code ourselves and recreate this change. So you can see the script here, adapted from the pull request. We load a different variant of the library with so version 3.1.1 and 3.1.2, where the optimization is included. We will see in a second how this works. We have preconditions, so this only works if we have opcache enabled on the CLI, because this is an opcache based optimization. Without opcache enabled on the CLI, it's not the code is not optimized. And we also need the sodium extension available. So I generate a 16 length random string, and then I encode the string 10 million times, and I also output something so that the opcache engine doesn't optimize this code away because it's not used. Opening the terminal, we will run Hyperfine, a benchmarking tool that allows us to compare two different command executions and run it in a way that allows statistical comparisons. We have a video about Hyperfine as well that I link in the description. So we call Hyperfine, and we want to make it a parameterized test with -l. So I want to have the version 3.1.1 and 3.1.2. And running each of them, I want to pass the version. And then what I need to make sure to fulfill the precondition, I also have to set opcache enable CLI. And then run this. So it now runs both commands 10 times. And then compares the performance against each other. So you can see in the output here, the first benchmarking run for each command was much slower. So this is a warning. However, since it's the case with both scripts, I'm going to ignore this. But generally, you want to make sure this warning doesn't appear, because it could mean that there is some noise on the system that skews the result of the benchmark. However, we can see quite well here the performance difference for the paragonie constant time library without the fix 3.1.1, 534 milliseconds, and with the fix we see 375 milliseconds. So we see that the script is 1.42 times faster with this performance optimization. I mentioned this is possible by only adding 2 backslashes, and that's what's in the pull request. However, if we compare the fixed version, we can see that the maintainer changed the code to not use the backslashes in front of the functions, but instead for string-lang extension loaded, they used the symbols at the top of the script, so you can do use function to import it from the global namespace, and this has the same effect of avoiding this expensive lookup. Tim recorded a 30% performance improvement by doing these changes, the constant time encoding, and my change was a little bit less than 30%, but it also showed like there's a big improvement by doing this. And if you have internal functions that have this opcode optimization in the engine, then and it's called in the hot pass of your application, then it's a really great optimization to get a lot of milliseconds out there at a very reasonable, simple change, just importing or adding the backslash. And it's good to know about this optimization if you have code that is very hot. It's run quite a lot of times. Algorithms over loops that are called thousands or 100,000s of times. In our previous videos, you can also see a list of all these optimized functions. We also have a blog post. Links are in the description. And I would be really happy if you subscribe to our channel to learn more about PHP performance. And there's also a newsletter where you can get information about new videos and blog posts. Link is in the description. Thank you.